Bismillahirrahmanirrahim. In the name of Allah who is most merciful and the beneficent. I am Hamza Mumtaz from batch 14 BS Biotechnology. And today I am going to explain the topic of N-butanol. Let's first of all discuss about the introduction of N-butanol. N-butanol, also known as normal butanol or N-butyl alcohol, is a chemical compound with formula C4H9OH. It is a colorless, flammable liquid that belongs to the class of alcohol, and butanol is derived from the butane molecule and is commonly used as a solvent, industrial intermediate, and chemical building block in various industries. And butanol is a versatile chemical compound with various industrial applications, ranging from solvent and intermediate in manufacturing process to a potential biofuel and additive. Its properties make it valuable in many industries, contributing to the production of numerous everyday products. Physical properties. It has various physical properties such as molecular formula, which is C4H9OH, molecular weight is 74.12 grams per mole. Appearance and butyl is a colorless liquid, although it has a characteristic sweet alcoholic odor. Density. The density of N-butanol is approximately 0.81 grams per centimeter cube. Melting point. The melting point of N-butanol is minus 89.8 degrees Celsius, also minus 1 to 9.6 degree Fahrenheit. Boiling point. The boiling point of N-butanol is around 117.7 degrees Celsius to 43.9 degree Fahrenheit. Solubility. It is soluble in water, ethanol, and most organic solvents like dissolved like tools. Refractive index. The refractive index of N-butanol is about 1.398. Let's discuss about the chemical properties of N-butanol. Functional group. N-butanol contains a primary alcohol functional group hydroxyl attached to a saturated carbon chain. Second, reactivity. As an alcohol, butanol can undergo typical alcohol reactions including oxidation, esterification, and substitution reactions. Three, combustibility. And butanol is flammable and can form explosive vapor air mixture. Hydrogen bonding. It can form hydrogen bond with water molecule due to the presence of the hydroxyl group. Acid-base properties. And butanol is a weak acid and it can react with strong bases to form butoxide salt. It can also undergo a salification reaction with acid. Miscibility. It partially miscible with water, meaning it can mix with water to some extent, but can also form separate layers. Vapor pressure. The vapor pressure of butanol is relatively moderate. Stability. And butanol is relatively stable under normal conditions, but it can react with strong oxidizing agents. Industrial applications of N-butanol. Number one, solvent. N-butanol is commonly used as a solvent in various industries. It is an effective solvent for paints, coating, varnishes, resins, dyes, and inks. Its ability to dissolve both polar and non-polar substances make it versatile in different formulations. Chemical intermediate. And butanol serve as a chemical intermediate in the production of various chemicals. It is used as a raw material for the synthesis of other compounds such as butyl acrylate, which is an important monomer for producing polymer like acrylic extract. It is used as extractant in the extraction of pharmaceutical, natural products, and organic compounds. Its ability to selectively extract specific compounds from mixtures make it useful in various extraction processes. Fuel and fuel additives. N-butanol has been explored as a potential biofuel and fuel additive. It can be blended with gasoline as an alternative fuel source due to its higher energy content. Compared to ethanol, it is considered a promising biofuel candidate. Now I'm going to explain some health and safety precautions and concerns of N-butanol. Number one, flammability. N-butanol is a flammable liquid and vapor. It can form explosive mixture in the air. Take approximate precaution to prevent ignition sources such as open flames, sparks, and hot surfaces in area where N-butanol is stored or used. Inhalation. Inhalation of van-butanol vapor can cause irritation to the respiratory system, including the nose, throat, and lung. It can cause dizziness, headache, nausea, and its high concentration. It may lead to central nervous depression. Ensure proper ventilation in area where n-butanol is used and consider using respiratory protective protection if necessary. 3. Skin contact. Prolonged or repeated contact with N-butanol may cause skin irritation and dryness. It can also be absorbed through the skin. Avoid direct contact with the N-butanol and use appropriate protective clothing such as gloves and long sleeves. When handling it in case of skin contact, wash the affected area thoroughly with soap and water. Number 4, eye contact. N-butanol can cause severe eye irritation and damage in case of eye contact and immediately flush his eyes with water for at least 15 minutes while keeping the eyelids open. Seek medical attention if irritation persists. Ingestion. Ingesting albuterol can cause gastrointestinal irritation, nausea, vomiting, and other adverse health effects. Now let me discuss the environmental impacts of albuterol. Biodegradability. Albuterol is biodegradable, which means it can be break down by microorganisms in the environment. This property makes it less resistant and potentially less harmful compared to some other chemicals. Aquatic toxicity. While albuterol is generally considered to have low acute toxicity to aquatic organisms, it can still be harmful to aquatic life, especially at higher concentrations. Care should be taken to prevent the release into water body as it can affect aquatic ecosystem or organisms. Volatility. 3N-butyl has moderate volatility, meaning it can evaporate into air. The release of N-butyl vapors into atmosphere can contribute to air pollution. However, where volatility it lowers compared to some other volatile organic compounds. Ozone formation. And methanol is not a significant contributor to the formation of ground level ozone, which is a harmful air pollutant. Ozone formation is typically associated with the presence of VOCs and nitrogen oxides in the atmosphere. Spill and waste disposal. Spill or improper disposal of methanol can lead to contamination of soil, groundwater, and surface water. It is essential to handle and dispose of n-butanol according to proper waste management practices and comply with local regulations. Renewable feedstocks. N-butanol can also be produced from renewable feedstocks such as biomass as part of the biofuel industry. Utilizing renewable feedstocks can help reduce the overall environmental impacts associated with the production and use of n-butanol. The current researches on n-butanol are biofuel applications. N-butanol is being explored as a potential biofuel and fuel additive. Researchers are evaluating its stability for blending with gasoline and assessing its combustion characteristics, engine performance, emission, and compatibility with existing infrastructure. Ongoing studies aims to optimize n-butanol blend for improved fuel efficiency and reduce environmental impact. Advanced conversion technologies. Novel conversion technologies such as bioelectrochemical system and enzymatic catalysts are being investigated for the production of albuterol. These approaches offer the potential for more sustainable and efficient conversion processes. Industrial applications. Research continues to expand the application of albuterol in various industries. Efforts are focused on developing new formulation, optimizing its use as solvent, exploring its potential as a chemical building block for high-value products, and investigating its compatibility with different materials and processes. Environmental impact. Studies are being conducted to assess the environmental impact of n-butanol throughout its life cycle, including its production, use, and disposal. This research aims to identify and minimize potential environmental risks associated with n-butanol, such as its release into water bodies or emission during fueling combustion. Technological innovation. Advances in separation and purification techniques such as distillation, absorption, and membrane technologies are being explored to improve the efficiency and sustainability of butanol recovery process. Here are some future prospects of n-butanol. The future prospect of n-butanol involves a shift toward more sustainable and renewable production methods, increased utilization as a biofuel or fuel additive, and expanding its application across various industries. Continued research and technological advancement are expected to enhance the economic viability, environmental performance, and broader adoption of NBTON in the coming years. That's all my presentation. Thank you for listening.